Good morning, good afternoon, good evening, whatever and wherever you are. My name is Hannah Rochelle, and today we are going to talk about some middle school geometry. The first thing that we're going to talk about are solids. So these are some questions that a student sent in to just get some help on things that they missed in class. So the first question talks about you're asked to help make a design. You're asked to help design a skating rink for the local skate park. Would explain which common solids you would choose to make the terrain challenging for and fun for all skaters. So ideally, we're not using square blocks. And actually, I'm going to pause the recording so that I can get some blocks. So my thoughts are we're not going to have these kinds of like cubes or rectangular prisms that we are going to use in a skate park because realistically speaking, if I'm skating, like I have to jump up, or maybe I can use this, jump up and then skate on top and then skate down. I would think more of like a ramp style. For example, a triangular prism would probably work best. Um, Maybe not like this type of equilateral triangular prism, maybe one that's a little bit more kind of like, I don't know, flatter so that there's like more of a ramp. I would also not recommend this kind of solid. This is not a great solid. This pyramid, maybe if it were a little bit more flat on the top. So for example, if we had, I have so many shapes, so many different shapes. Maybe like a half sphere, we could do that. There's lots of different shapes. You just have to be able to explain why. I don't know that this kind of shape would be super helpful, but I have these shapes also. So all of these different shapes are totally acceptable, I would imagine, except for like a full sphere and except for probably even like a cylinder like this, kind of like a soda can, if you will. Um, Probably because they're a little bit too round and it's going to be way too hard for them to skate onto. So if you can make a case for why you can skate onto that shape, then absolutely, I would say you've made your case for that particular point. Okay, so let's go ahead and so I would say that's done. Once you can choose a shape and then you can go in and explain why that shape is, assuming that you're skating, and then getting up on something and then skating again and then going down. Clearly, you can tell I am not a skater. Okay, a figure has three lateral faces that are rectangles. Okay, so a lateral face is kind of like this, and this. So this one has three lateral faces that are rectangles. Name the figure. This is going to be a triangular prism, and it's a triangular prism because the bottom and the top are triangles. So therefore, because they're exactly the same, they're going to be prisms. And because the bottom and top are triangles, they are also going to be a triangular prism, not just a regular prism. Okay. This one says find the measure of the supplement of each angle. We know that supplementary angles are, let's assume that's a straight line. They add up to 180 degrees. So for example, if this is 100 degrees, this is 80 degrees, I can add them together to get 180 degrees. So for all of these, I would just take 180 and subtract whatever the degree is in order to get the actual degree. So that would be 118. Sometimes it might make sense to subtract this way instead of like side to side, because then you can go ahead and borrow. So you'd end up with 66 degrees for this. Then I have 180 degrees minus 93. This is kind of nice because I know 180 minus 90 is 90. So then I know just 90 minus 3 is going to be 87 degrees. and then 180 minus 148. They could ask you also, instead of just supplements, complements. Sorry, this is going to be 32 degrees. So a supplement is something that creates 180 degrees. A complement is something that creates a 90 degree. So they'll add up to 90 degrees. One of the ways that I like to show, that's a weird looking at. So I have supplementary and then I have complementary, right? So I like to go, hey, this is 180 and this is 90. So that's a nice way to remember, like, oh, what do supplementary angles add up to? What do complementary angles add up to? And this is where you have it. All right. Thank you so much for watching this, and I will see you in another video. Bye.